A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever ANITA has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. ANITA is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Whistle explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
Welcome to one of the most mysterious and unexplored places on Earth. But what's so special about that? It's just some icy peaks and the endless snowy expanse of Antarctica. Yeah, that's right, but there's still a planetary scale mystery here. No matter how hard you try, you won't see a hidden mountain range, giant, unexplored land where no human has ever set foot, and it lies under another layer of mountains. It's like a nesting doll, but the size of a continent. These mountains hide Antarctica secrets, and these secrets can tell us something awesome about the ancient history of our planet. This gigantic unexplored territory in Antarctica is called the Gambritsev Subglacial Mountains. And the layer of ice above keeps this place untouched by nature and people. It's like a land inside another land, and it hides more than just mountains. There are valleys, hills, and plains. The whole area is similar to the European Alps, but unfortunately, we can't enjoy the view. Those mountains were first discovered in 1958 using seismological instruments. More than half a century has passed since then, and this place still remains one of the most poorly studied tectonic objects on Earth. Why? Because it's ice. A lot of ice. Who knows? Maybe there are some unknown ancient artifacts lying there. What if they're hiding a secret city or spaceships? It's unlikely, of course, but it would still be interesting to look there. Think about it. Hundreds or even thousands of miles of land that have remained unchanged for hundreds of millions of years. Even if no new species of animals or remains of an ancient civilization are there, this place still has a history. The history of the formation of continents on our planet. And scientists have already figured out some of this story. The mountains buried in Antarctica were originally like ordinary mountains, but as a result of a planetary scale event, they just… Wait a minute. Have you ever wondered how mountain ranges are formed? We see them in real life, in movies, in photos on the internet. We climb them. But how did they appear? Mountains have not always existed on the planet in this form. They appeared as a result of a large-scale collision of tectonic plates. Two giant solid chunks of ground are moving toward each other, then crash, and boom! Millions of tons of the Earth's crust pile on top of each other, mix, and form ledges and gorges. And all this can last for millions of years. Yes, it's a disaster, but it's very slow. Some tectonic plates are still colliding. For example, the Himalayas continue to grow because the Indian and Eurasian plates are still ramming into each other. And this process began about 50 million years ago. The Gambritsev Mountains under ice experienced a similar event, only much earlier. An article in the journal Earth and Planetary Science Letters says that they appeared during the formation of the supercontinent Gondwana. Two giant pieces of land were separated by a boundless ocean. But then, about 700 million years ago, they collided and formed Gondwana. This supercontinent included the territories of modern Africa, South America, Australia, India, and Antarctica. The giant pieces crashed into each other and released a stream of hot, partially molten rock. This mess grew bigger and bigger, forming mountains. The temperature of those mountains grew, their mass increased, and at some point, Gondwana became unstable. The supercontinent began to collapse under its own weight. The hot rocks below the surface began to flow sideways as a result of a process called gravitational spreading. Take toothpaste and start squeezing it out of the tube. Approximately the same thing happened with billions of tons of red-hot rock. Ancient mountains in Antarctica appeared right during this catastrophic event. You've just watched a visual simulation of global events that took place hundreds of millions of years ago. It looks cool, but how did scientists figure it out? How did they see this planetary scale destruction? If the Gambritsev Mountains under ice is one of the most unexplored places in the world, then how could people find out its origin? The answer is simple. Tiny particles of rock have told us about the changing landscape of the planet. These are zircons, but scientists also call them time capsules. This mineral is very handy and resistant to mechanical and chemical influences. It's difficult to crush, it doesn't get affected by erosion, and it doesn't dissolve in water. And there's uranium inside it. This chemical element shows scientists the age of the rock. The fact is that uranium always decays into lead at the same rate. Scientists look at the ratio of uranium and lead and determine the age of minerals with great accuracy. Okay, this sounds a bit complicated. Here's a simple example. Imagine that each mountain belt is a clock that starts ticking at the moment of its formation. That is, after the collision of tectonic plates. After the rock forms, uranium begins its slow decay. The more time passes, the more uranium turns into lead. The rate of this decay is always the same. This decay can last for billions of years. The less uranium is in zircons and the more lead, the older the rock is. And this is how it happens in practice. Geologists take several rock samples. In a lab, they crush it to extract crystalline zircons. Geologists then dissolve the particles in acid to separate uranium from lead. Then they use a special device, a mass spectrometer that accelerates atoms and sorts them by mass. This is a rather complicated process, but the bottom line is that this device shows scientists the amount of uranium and lead. They look at the ratios of these two elements and calculate the age of the rock. Geologists took zircons from sandstones near the Gambritsev Mountains, studied those particles, looked at the level of uranium, and calculated the chronology of mountain formation. Then they compared the data obtained with the history of our planet and realized that the mountains buried in Antarctica appeared during the formation of the supercontinent Gondwana. But how did they find out that the supercontinent included Australia, India, and Africa? Zirconia from those Antarctic rocks turned out to be very similar to zirconium from those countries. That is, a long time ago, these three continents were together. So, the Gambritsev Mountains began to grow about 650 million years ago. About 580 million years ago, they reached the height of the Himalayas, and 80 million years later, they experienced the melting of the Earth's crust. And while most of the mountain ranges on the planet were changing and collapsing, the Gambritsev Mountains under ice remained untouched. Water, soil, wind, earthquakes, gravity, and other natural forces destroy mountain belts. This process is called erosion. But mountains buried in Antarctica haven't experienced anything like this. The cold temperature and the ice sheet around them kept this range unchanged. It's one of the best preserved ancient mountain belts on the planet. Okay, but why do we need to explore these mountains? What difference does it make that the supercontinent Gondwana collapsed in the past? It's possible that plants, frozen bodies of insects, or ancient bacteria have remained preserved under thick layers of ice. What about ancient animals? Many species could have lived on Gondwana. Studying ancient mountains in Antarctica can show us what the planet looked like about 500 million years ago. When Antarctica was a green continent, what lived on it? What happened to this life? Is it possible to revive those ancient creatures after so many years? If scientists were able to calculate the date of the supercontinent's appearance using tiny particles, then imagine what they could find after examining this hidden mountain range. It all sounds very interesting. But there's one problem. To take a small piece of this unknown world, you need to drill through a lot of ice. You need to deliver heavy equipment to one of the most inaccessible continents in the world, build stations, obtain an energy source, and conduct large-scale research. It sounds incredibly expensive, so this hidden territory will probably remain a mystery for a long time. Let's just hope that some billionaire will want to find out Antarctica's secrets and arrange a large-scale expedition there. Giant vase-like sponges, otherworldly jellyfish, segmented worms covered with bristles, and large octopuses are the newest Antarctica discovery. Scientists found them after a giant iceberg had broken away, and it turned out to be a treasury of ancient life under ice. In January 2025, a huge iceberg the size of Chicago, called A84, broke off from Antarctica's George VI ice shelf, which is a large ice shelf about 280 miles long, 12 to 43 miles wide, and around 820 feet thick. In the summer, which lasts from November to late February, the ice shelf melts at the surface, and meltwater ribbon lakes form. They're elongated and ribbon-like. That's how they got their name. Anyway, when the iceberg floated away, it left part of the ocean floor wide open, and it was a spot no one had ever seen before. Scientists on the research ship Falkor 2 were nearby in the Bellingshausen Sea. As soon as they heard about the iceberg, they immediately changed their plans. They understood that it was a super rare chance to check out something unknown and amazing, like lifting a rock in the forest to see what's hiding underneath. The researchers used an underwater robot named Sebastian and explored the deep sea for 8 days. They went as deep as over 4,200 feet. Down there, they found a hidden ecosystem. There were big corals and sponges literally packed with sea animals. A whole world under the ice. The researchers thought they'd find some life down there, but they didn't expect to see so much. And this underwater ancient life wasn't just surviving, it had been thriving in that harsh, icy place for a really long time. Anemones that looked like fluffy little trees, sea spiders, ice fish, octopuses. The research was live streamed to scientists from all over the world, and those live streams are actually in open access. The coolest thing was that some discovered creatures seemed to be new species. Yes, there are probably new species in Antarctica in 2025, and some might only live in this region. That's because Antarctica isn't just really far away. It's been cut off from the rest of the world for millions of years. The Antarctic circumpolar current surrounds it, like a big water moat surrounding a castle. But even if it turns out that those species are not new, the scientists have still found snails, worms with bristles, crustaceans, like tiny crabs and shrimp, and a species of the phantom jellyfish. Those are super rare and look otherworldly. Their official name is too complicated, so let's just call them the giant phantom jelly. This jellyfish is huge. Its bell, the round umbrella part on top, can be more than 3 feet wide. It has 4 long arms that trail behind it. Each one as long as 33 feet, about as long as a school bus. Scientists first caught one way back in 1899, but it took them 60 years to realize it was a totally new kind of jellyfish. The phantom jellyfish has a see-through purplish body that looks kind of ghostly. Instead of normal jellyfish tentacles, it has these ribbon-like arms that help it catch food and pull it into its mouth right in the middle. Even though jellyfish don't have brains like we do, researchers watching the giant phantom jelly noticed something surprising. The otherworldly creature seemed to move its arms very carefully and with control, especially when swimming through tight spaces on the seafloor. It looked like it was being very cautious and deliberate. Ugh, creepy. Another sentient being? Jellyfish have a simple nerve net instead of a brain, which helps them sense the world around them. But the way this phantom jelly moved made scientists think it might be smarter or more coordinated than other jellyfish. Studying it can help scientists learn how animals without brains still manage to explore and survive in tricky places underwater. Another cool find was little worms called bristleworms. Scientists call them polychaetes. But let's stick with bristleworms because it kinda sounds fun. Lots of different kinds of them live in super cold, deep parts of the ocean. Bristleworms have bodies made of many segments, and they have tiny little bristles all along their sides. These bristles help them move around, feel what's near them, and even protect themselves from danger. One cool example is the Antarctic scaleworm. It's a type of bristleworm that lives in really cold, deep waters and has shiny, golden bristles that make it look pretty fancy. During Antarctic deep-sea exploration, the team also found giant sponges shaped like vases. Usually, sponges grow very slowly. So to get that huge, they must have been growing there for a really long time, maybe even hundreds of years. Their size shows that the deep-sea animals living around them didn't just move in recently. Those sea creatures have been there for decades and managed to form thriving communities under the ice. So, it really was ancient life hiding under all that ice. And that surprised scientists a lot. In older studies, people used to drop cameras through holes in the ice or visit iceberg areas long after the ice had broken off to explore hidden ecosystems. Back then, they mostly saw bare, empty seafloor with just a few living things. But this time, the team arrived just weeks after the giant iceberg broke away, and they got to see what was hiding right underneath it. The first 9 miles behind the ice shelf can hide rich and busy ecosystems. The area is dark, cold, and hidden for ages. and still, all kinds of creatures live there. This shows that life can survive in places that seem too harsh or frozen for anything to live. On the other hand, finding all this life down there isn't super surprising. Lots of animals live in dark, cold places underwater, so it makes sense that they'd be under the ice shelf too. The ice kind of hides them and keeps them safe from anything going on above. But what's weird is how many different kinds of creatures live there, even though it used to be a really closed-off space. It actually looks a lot like the seabed in parts of Antarctica that don't have ice on top. How can that be? Usually, tiny plants called phytoplankton grow near the surface where sunlight hits. Little shrimp-like animals called krill eat those plants at night. When krill get full, they sink down and bring food and nutrients to the ocean floor. Even their waste helps feed the deep-sea creatures. But if there's a huge ice cap above, sunlight can't get through, so no plants can grow there and no krill bring food down that way. Scientists thought this would mean less food and fewer animals down there, but they found a lot of life anyway. Turns out, food and nutrients probably sneak in under the ice, carried by underwater currents, kind of like rivers flowing under the ocean. Scientists found some animals that lived a long time, so it looks like those currents, which mostly come from melting glacier water, bring enough food to keep the ecosystem healthy and full of life. No one really knows what's going to happen to all that deep-sea life now that the iceberg has floated away. Those creatures have lived under the thick ice for who knows how long, in super stable, pitch-black conditions. Obviously, they're not exactly fans of change, so losing that icy roof might totally mess with their whole setup. One of the scientists mentioned that the ice shelf the iceberg came from has been creeping backward, like 25 miles over the last 50 years. That's a part of a bigger pattern. Antarctica's ice is melting faster and faster, which pushes sea levels up around the world. That's why this Antarctica discovery matters. The team's trying to figure out not just what's happening now, but how this hidden ecosystem fits into the bigger picture. If we can understand how this place is changing over decades or even centuries, maybe we can predict what's coming next. And it's pretty amazing that breaking ice can tell us so much, right?